Hello, Phil from statisticsmentor.com. What's the chances of winning a lottery when you have to match 5 balls from 20? This is a problem that we can all easily understand, and it's an exercise in counting. So recall that the probability of the event is equal to the number of ways that the event can happen divided by the total number of possible outcomes. To solve it, in this case, I'm going to use the fundamental theorem of counting. It's a rather grand title. It also goes by the name of a multiplication principle. And the multiplication principle says that, say we've got two experiments. One experiment has, say, n outcomes, and the second experiment has p outcomes. Then the total number of outcomes in the composite experiment, being experiment 1 followed by experiment 2, has m times p number of outcomes. And we can extend that to however many experiments we're dealing with. So an example is, suppose I have a 1 dice, which 6 sides, and a coin, which has 2 outcomes. Then the total number of possible outcomes from throwing a dice and tossing a coin is 6 times 2. Say I've got a dice and I roll it 5 times. Then the total number of possible outcomes from doing that will be 6 to the power of 5. Why? Because the dice has 6 sides, each time you roll it, 6 outcomes. The multiplication principle says you multiply the number of outcomes in each experiment. So I'm going to use that here to find the probability that you can match 5 numbers from 20. Now, I think lottery works all the same all around the world, except for these numbers here might change. But what happens is that you draw numbers without replacement. First, I want to calculate the number of total possible outcomes, This will be in the denominator to calculate the probability. Now the first ball, can be drawn in 20 ways because there are 20 balls. The second ball can be drawn now in 19 ways because one has been drawn and it's without replacement. Third ball drawn 18 ways, 18 balls left. Fourth ball drawn 17 ways. Fifth ball, final ball drawn 16 ways. The multiplication principle says that the total number of ways is the multiple of all these individual ones. So if we multiply this, so, and that comes to, what does that come to? Okay, it comes to that many ways, approaching, well, 1.8, it's 1.9 million ways. And that's the bottom bit taken care of. Now we need to calculate the number of ways of my 5 balls coming out. The number of ways of the winning balls being drawn, we are counting now, but with a restriction. The restriction is that there are 5 particular balls. Okay, 5 particular balls that make up the winning ones. So if we draw the first ball out of the 5 winning balls must be 5, because there are 5 winning balls, and the first ball can be any one of those 5. The second one, well, since the first one has been one of them has been drawn, you're left now with only 4. See, 3, 2, until the final ball. There's only 1 winning ball left among the rest of the balls. That's 1. And FTC says that the total number of ways of doing that is the multiple of all these guys. And that comes out to be 120 ways. which is a very small probability. We could write this in decimal places, but I'm not going to bother. Okay, so that is using FTC. There are other ways of doing this, and I like to use a lottery example because I can demonstrate them. So in the next series of videos, I'm going to do that. Okay, so that's the one done with using the FTC.